Prenatal screening offers a stark choice for any woman carrying a fetus that has tested positive for a genetic disorder: to terminate or not to terminate the pregnancy. The fact that amniocentesis cannot be performed until a fetus is at least 15 weeks old makes the option of termination only more traumatic. At this stage, an abortion does not eliminate a featureless ball of cells, but a tiny being, real enough that a parental bond may have already formed with the developing fetus, thanks to the power of ultrasound imaging. Most parents, at least those who do not oppose all abortion on principle, would infinitely prefer to make hard choices presented by genetic testing at an earlier stage of development. Such was the inspiration for the invention of pre-implantation diagnosis. Robert Winston at the Hammersmith Hospital in London is a leading gynecological microsurgeon, an expert in such procedures as the correction of fallopian tube defects that prevent a woman from conceiving. He has also become one of British television's leading popularizers of science and biomedical research, and even finds time, as Lord Winston of Hammersmith, to sit in Parliament, advising the government on such matters. By combining two state-of-the-art technologies, in vitro fertilization, IVF, and PCR-based DNA diagnosis, Winston pioneered a method for checking the genetic status of an embryo before it is implanted in a woman's uterus and begins to develop. IVF is a method of assisted reproduction in which sperm and egg are fused in a laboratory dish. The resulting embryo, rather ominously called a test tube baby in the early days of the technology, is then transferred to the uterus to develop naturally. After in vitro fertilization, the several conceptuses are grown in the laboratory until each fertilized egg has divided 3 or 4 times to produce a ball of 8 to 16 cells. 1 or 2 cells are carefully removed from each for DNA extraction, and then PCR is used to amplify the relevant sequences to determine in each case whether or not a mutation is present. It is the astonishing capacity of PCR to amplify even the tiniest quantities of target DNA that makes possible this method of ultra-early diagnosis. Parents are then free to implant only those embryos that test negative for genetic disease. The first pre-implantation tests performed in 1989 screened for the sex of the fetus, important information, when the risk is for a sex-linked disorder such as DMD. A mother who is a carrier may select only female embryos on the premise that they will not be affected by the disorder, though they may be carriers. It was Winston's colleague, Alan Handyside, and others who subsequently extended pre-implantation diagnosis beyond simple sex determination to the detection of specific mutations. In 1992, they first applied the technique to screen for cystic fibrosis, which is not sex-linked. As we have seen, despite being sex-linked, Fragile X can affect both males and females. The disorder is therefore a natural target for gene-specific pre-implantation diagnosis. But it still took impassioned parents familiar with the difficulties of raising a Fragile X child to mobilize doctors to do it. Debbie Stevenson, a CNBC television news reporter, has a son, Taylor, whose Fragile X was only diagnosed after the birth of a second son, James. Though James fortunately beat the 50-50 odds of being affected, the Stevensons were unwilling to trust their third child to fate. They decided to seek pre-implantation diagnosis. Some people think it's unethical to select for healthy embryos, says Debbie Stevenson, but I think it's better than having to make the wrenching decision about whether to terminate or continue a pregnancy after learning that your baby has a significant disorder. In 2000, at the end of the family's frustrating year-long search For a lab willing to carry out the procedure, the newest member of the Stevenson family was conceived and just days later tested for Fragile X. Like James, Samantha is free of Taylor's debilitating disorder. In our culture, human reproductive biology seems an inexhaustible source of controversy, and a procedure involving the manipulation of human embryos for any purpose is sure to become a lightning rod. Pre-implantation diagnosis has been no exception. Ethical considerations aside, however, the procedure still has two major drawbacks. It requires a huge commitment on the part of the couple undertaking it, and like all forms of IVF, it is very expensive. But the method is so powerful in principle and so much less traumatic than abortion, one can only hope that with time we shall see improved techniques, and with them diminished cost, the usual pattern with developing technology. Pre-implantation diagnosis has the potential to become an extremely important weapon in our war on genetic disease. The disorders we have discussed so far are all simple in the genetic sense. They're caused by a mutation in a single gene, and environment has no bearing on whether or not you'll get one of these diseases. The situation is rather more complicated in the case of illnesses like cancer, which, as we've seen, may be triggered by a combination of hereditary and environmental influences. But even with cancer, there are some individual genes that have a major effect, regardless of the environment. Though BRCA1, one of the genes implicated in breast cancer, only accounts for about 5% of all cases, women with mutations in the gene have an estimated 90% chance of developing the disease by the age of 60. In the early 1990s, Francis Collins, then at the University of Michigan, joined forces with Mary Claire King at UC Berkeley in the hunt for BRCA1. They took the standard approach, collecting families, preparing DNA samples, and testing markers, all with a view to homing in on the gene. One family of more than 50 members included multiple cases of breast cancer, a clear instance of an inherited predisposition to the disease. In September 1992, one member of that family, I'll call her Anne, revealed to Barbara Weber, an associate of Collins, that she had scheduled a bilateral mastectomy the following week, even though there was no sign that she had cancer. Anne had decided that she could no longer tolerate the uncertainty, the question mark hanging over her future, and preferred to take this drastic preemptive step. Weber, however, had concluded from the DNA analysis that Anne was actually not in particular danger. Her risk of breast cancer was no greater than that of a woman without a family history of the disease. But this inference was made in the context of a research project, and it had been agreed long in advance that, as a rule, such preliminary data should not be used for clinical diagnosis. Weber and Collins, however, decided that Anne's plight outweighed the rule book. They informed Anne that her risk was low, and, with great relief, she canceled the surgery. But having disclosed their findings to one member of the family, the researchers felt obliged to offer the same benefit to others who asked for it. And so Weber and Collins set up an ad hoc breast cancer genetic counseling program. One family member, who also proved to be at no special risk, had already undergone a prophylactic bilateral mastectomy 5 years before. She received the belated diagnosis philosophically. The surgery, she figured, had bought her 5 years' peace of mind. But had she tested positive for the mutation, the radical course might in fact have bought her